Welcome to the Oracle Policy Automation tutorial introducing rule components. In this introduction, I will describe to you the primary components of a rule and explain how those components are combined to express both simple and increasingly complex rules and policies. A rule asserts that a set of conditions or circumstances leads to or implies a logical conclusion. All rules have at least one conclusion and usually have one or more conditions. A conclusion is the fact, result, or determination that is known to be true when a given set of conditions are satisfied. For example, in an if-then statement, the conclusion would follow the then, as in, if the claimant has reached pension age is true, then conclude that the claimant is eligible for an aged pension is true. A conclusion need not be positive. For example, if the claimant is a foreign citizen, then the claimant is not eligible for an aged pension. All rules in Oracle policy modeling are assumed to have an implied and automatic opposite conclusion. That is, if the set of stated conditions is known to be false, then the opposite of the stated conclusion must be true. A condition is a circumstance or state of affairs that must be true in order to reach a conclusion. For example, a condition is the if part of an if-then statement, as in, if the claimant has reached pension age is true, then conclude that the claimant is eligible for an aged pension is true. Like conclusions, a condition need not be positive. For example, if the claimant is not a US citizen, then conclude that the claimant is ineligible. Regardless of whether conditions are expressed in positive or negative form, every condition and set of conditions can have one of two values, true or false. Where a rule contains multiple conditions, they must be connected by either an and or an or to clarify the logical meaning of the combined conditions. For example, the claimant is a US citizen and the claimant is over the minimum retirement age. On the other hand, the claimant is a US citizen or the claimant has a green card. So let's take a look at the logical meaning of the AND connector. As you can see in the first row of the table, for the combined conditions to be true when using the AND connector, all conditions must be proven true. If any of the conditions are proven false, then the combined conditions will also be false. Now let's take a look at the logical meaning of the OR connector. The first thing you will notice is that unlike using the AND connector, where all conditions must be true for the combined conditions to be true, the OR connector requires just one of the conditions to be true. It is only when all conditions are false that the combined conditions will also be false. Conditions can be combined using the AND or OR logical connectors. As you can see, logical connectors are not limited to combining just two conditions. In fact, there is no limit to the number of conditions that can be combined. Note that any set of combined conditions must be consistently connected by either AND or OR. Mixing these two connectors in a single set will result in ambiguity in the logic. Now let's look at a few examples of using connectors. We have already learned that where the AND connector is used in a rule, all conditions must be proven true for the rule's conclusion to have a result of true. As one condition here is false, the result is false. But what happens when one of the conditions is unknown, meaning you do not have a value for the attribute? First, we see that one of the conditions is true and it is possible that the rule's conclusion could be proven or not proven depending on whether the second condition is true or false. The conclusion is unknown until such a time as we have the value for that second condition, and so the result is unknown. In the next example, however, one of the conditions combined with AND is false, so the combined conditions are known to be false as well. Where two or more conditions at the same level are connected using OR, just one of those conditions needs to be true for the rule's conclusion to be proven. Therefore, in this case, as both conditions are true, the result is true. Next, we see that both conditions are false, in which case the result is also false. Where one condition is false and the other unknown, the conclusion cannot be effectively proven or disproven, so the result is unknown. We previously covered the point that conditions and conclusions may be expressed in the negative. By writing a rule as shown in this example, Oracle Policy Modeling recognizes a negation and infers the result appropriately. Note that the same logic applies to negative conclusions. Firstly, we see the person is both poor and sick. As the second condition was that the person not be sick, the result is inferred as false. Next, the person is poor, but the person is not sick, meaning both conditions have been met, and so the result is inferred as true. And lastly, we have a person who is not poor and not sick. While the second condition has been met, the first has not, and as we are using the AND connector, the result is inferred as false. We invite you to learn more about Oracle Policy Automation and stay connected with our active communities. Please take a moment to study this slide so that you will know where to find us whenever you need us.